Hello, my name is Rebecca Rivera, and I will be talking about architect Frei Otto. Frei Otto was a German architect and structural engineer known for his use of lightweight structures, particularly tensile and membrane structures. Otto was born in Segmark, Germany, and raised in Berlin. He studied architecture in Berlin before being enlisted in the Luftwaffe as a fighter pilot during the final years of World War II. He was captured as a prisoner of war at a camp near France, where he trained as an aeronautical engineer. He began experimenting with tents for shelter for his fellow prisoners of war. After the war ended, he briefly studied in the United States and visited respected architects Eric Mendelsohn, Mies van der Rohe, Richard Neutra, and Frank Lloyd Wright. Otto dedicated his career to studying the mathematical purity of structures that occur in the natural world. He discovered that the physics of coral reefs, spiderwebs, and soap bubbles held the answer to constructing the most efficient buildings. He quoted, "We have used many models from nature to develop new structures." Otto was a pioneer in structural mathematics and civil engineering, specializing in the lightweight, tensile, and membrane structures. In 1964, he founded the Institute for Lightweight Structures at the University of Stuttgart and headed the institute as a university professor until his retirement. His representative works included the West German Pavilion in the 1967 Montreal World's Fair, and the roof of the arena of the 1972 Munich Olympic Stadium. Perhaps one of Frei Otto's best-known projects was his design of the roof of the Olympic Stadium in Munich for the 1972 Summer Olympics. He believed that the tensile structure could be used to rebuild the post-war Germany into a peaceful country and show a way towards a lighter and brighter future for the world. The stadium was intended to present post-war Germany with a new appearance. With its new age and modern look, it was meant to stand in harmony in its surrounding environment. The design of the stadium was created by Bennett and Partners B&P. The concept proposal derived from taking advantage of the existing topography of the site and carving out the space out of the earth for the field and seating of 90,000 spectators. Otto created a design scheme consisting of tensile roofs of steel cable and acrylic panels which stretched over the Olympic Stadium site like one massive tent merged together. The canopy was designed to shelter the spectators and athletes, made translucent but designed to prevent any overarching shadows from interfering with the televised casting of the Olympic Games. Otto made the transition possible from the small-scale fabric structure to the large-scale cable net structure. He was also able to achieve large free spans by separating the cable net and cladding, in contrast to tent structures where the fabric serves both structural and weatherproofing functions. In the following images, you can see the tension areas, where the cables are being pulled, and the compression areas where the cables are being pushed by the forces. Here is an image that shows the stadium with its seating for 90,000 spectators for the Olympic Games, and the canopy arches over the bleachers, and it is also an open air structure, so we can see here how the arches are repetitive one after another, and we can see the tension that is caused in the various areas. Here you can see the hardware that supports the acrylic panels in place. The transparent panels are 4 millimeters thick plexiglass sheets, and they were colored light gray for better protection against the sun, in order to comply with the fire protection requirements. The material was especially stretched for this construction and treated with a special fire retardant. To accommodate for some movement in these areas of compression, the footings consist of rubber-bearing pads on concrete bases, and temporary steel balls were provided under the rubber pads to allow for rotation during its assembly. Otto passed away on March 9, 2015. Much of his research in lightweight structures is as relevant today as when he first proposed them over 60 years ago. His work continues to inform architects and engineers to this day. He was truly the father of tensile structures.